Hello students, welcome back again to our next video of mixtures. In the previous video we have already discussed the definition of elements, compounds and mixtures. Today we'll be talking about the different types of mixtures and their separation technique. Firstly, recollecting the definition of mixture, we had already seen that what is a mixture? A mixture is made up of two or more substances which can be elements or compounds or both mechanically mixed together in any proportion. And mixtures are broadly classified as homogeneous mixtures and heterogeneous mixtures. So let's understand these two terms. What does homogeneous and heterogeneous mixtures mean? We'll take the simple example of salt solution and sand solution. So by these example itself, it becomes very clear. In the first example, that is in the salt solution, you can clearly see that a clear solution is formed and no particles, suspended particles of salt are seen. It means it is forming a clear solution or a clear mixture is being formed. Whereas in the second example, you can see two separate layers are formed. One is of water and the second is of sand. And the properties, obviously when they are forming separate layers, we can say that the constituents are not uniformly mixed. Whereas in homogeneous, salt and water, they are uniformly mixed. But sand and water, they are not uniformly mixed. So what will be our first important difference between homogeneous and heterogeneous? Constituents are uniformly mixed. And for heterogeneous, what you are going to state? They are not uniformly mixed. The constituents are not uniformly mixed. Second point, the constituents and the properties and the composition will remain same throughout the solution. Properties and composition remains same throughout the mixture. And definitely here you can see that in mixtures, that is in heterogeneous mixtures, the composition and properties will vary. Okay, it is going to vary and it will not remain same throughout the solution. Few other examples of homogeneous mixtures which you can remember or note it down. First we have seen is a combination of a solid and liquid, that is salt and water, and in heterogeneous we have sand and water. Next example is of two solids. If we talk about two solids which are homogeneous, we take the example of copper and zinc. It forms a homogeneous mixture and they together form an alloy which we call it as the brass. Okay, then solid liquid we have already seen. Then we have two liquids. If we see the example of two liquids is two liquids, we can see the example of alcohol and water. And for two gases we have the example of air. So this is at times asked, air forms a homogeneous mixture or a heterogeneous mixture. So this is an important example. You will remember that air forms a homogeneous mixture. Now here for solid in heterogeneous heterogeneous mixture, we have the example of iron and sulfur. Solid liquid we have already seen sand and water, and liquid heterogeneous mixture is the example of oil and water. Okay, so examples are very important in this lesson. Next, talking about the separation of mixtures, you need to know that there are 6 different types of mixtures which you have to see. 6 types of mixtures, and we'll see their different types of techniques which are being used. First, I'll classify the 6 different types of mixture. Firstly, we have solid mixture. In solid mixture, we have got 4 methods to see. Firstly, we have the sublimation process. Sublimation. Then we have magnetic separation. Magnetic separation. Then we have solvent extraction. And the fourth separation technique is fractional crystallization. Fractional crystallization. Okay. So this is our first type of mixture, that is solid mixture. Secondly, we have second type of mixture will be solid liquid mixture. Here also in solid liquid mixture we have got 4 different methods. First is filtration. Filtration is there. The secondly we have sedimentation. These are methods which you have studied in your lower grades. Then evaporation and distillation. These are all these terms you have studied in your lower classes. These are simple to remember. Okay. So second type of mixture we have solid liquid. Third type of mixture we have liquid mixture. In this we have got 2 methods or 2 techniques of separation. We use the separating funnel, and the second is the fractional distillation. Fractional distillation. Okay. Then fourth type of mixture will be, fourth type of mixture which we have got is liquid gas mixture. And in liquid gas mixture we have just one method, that is boiling. Fifth type of mixture we have gas mixture. In this again we have 2 methods. We have diffusion. We have diffusion and we have solubility in solvent. Solubility in solvent. And the last type of mixture we have got is the complex mixtures. And in complex mixtures we have got 2 methods. One is centrifugation and the second is chromatography. Okay. So that summarizes, or you can say this is the mind map which you need to remember for the different types of mixtures are there. Firstly, the main point is there are 6 types of mixture. We have solid mixture, we have solid liquid mixture, then we have liquid mixture, we have liquid gas mixture, gas mixture, and lastly we have the complex mixture. Now moving to the first type of mixture, solid mixture, let's understand it quickly through this diagram. The first method is sublimation, and the principle behind sublimation is to separate the sublimable solid from a non-sublimable substance. Now we know that ammonium chloride undergoes sublimation. What is sublimation? Sublimation is a process when a solid directly changes into gaseous state without changing into liquid state. That is the meaning of sublimation. So we have taken ammonium chloride and sodium chloride and we have placed one inverted funnel and we start supplying heat energy. So what will happen? Ammonium chloride being sublimable, its vapors will rise and its vapors will get collected as solid ammonium chloride at the neck of the funnel. We have placed a cotton piece so that the vapors do not escape out. And what will be left behind? Sodium chloride. So which 2 solids we have separated? We have separated ammonium chloride from sodium chloride. Principle being behind here being that one is sublimable, the other is a non-sublimable solid. Second, from the diagram itself you can make it out very simple. This is magnetic separation. We are separating the magnetic substance from a non-magnetic substance. So what is magnetic over here? Iron filings are magnetic. So iron filings will be attracted towards the magnet, and what will be left behind in the dish? Sulfur will be left behind. So again we have separated two solids, iron and sulfur. Principle behind the separation is separating magnetic substances from non-magnetic substances. Next we have solvent extraction. Here we are taking the example of charcoal and sulfur. Now remember, very important, sulfur is soluble in carbon disulfide solvent. Okay, so what we are going to do? In this we have taken the solvent, that is carbon disulfide, and we are going to add this mixture of charcoal and sulfur inside the beaker. So what will happen? Sulfur will dissolve. Once it dissolves, what we are going to do? We are going to filter it out. With the help of the funnel, we are going to filter it out. So what will be collected? Inside the filtrate, we are going to get the sulfur which has dissolved in carbon disulfide solvent. In the filter paper, what will be collected? Charcoal will be collected because it is insoluble. It is not dissolving in carbon disulfide solvent. So here separation is based on soluble solids dissolves in solvent, leaving behind the other. So sulfur has dissolved, and this particular sulfur is present in carbon disulfide solvent. So we are going to evaporate this solution. Once we evaporate it, what is going to happen? We are going to get the sulfur particles left behind. So this is a simple method by which we separate the sulfur from charcoal. Again, two solids we are separating. The method which we are using is called as solvent extraction. Solvent extraction. Moving to the last method in solid-solid mixtures, we see fractional crystallization. Now here we have taken two solids. Now out of these two solids, one is more soluble than the other. Potassium nitrate is more soluble as compared to potassium chlorate. It is less soluble. So this point you have to remember. Which is more soluble? The nitrate is more soluble as compared to potassium chlorate. So what is going to happen? Firstly, we are going to prepare a saturated solution over here. How we prepare a saturated solution? By dissolving the two salt solutions by constant stirring and by heating it. So what will happen? When we are going to heat it, the two solids are going to dissolve in it to form a hot saturated solution. We'll keep adding till no more of the salt dissolves in that solution. At that time we say that we have prepared a saturated solution. Now we are going to cool it. Once we cool it down, what is going to happen? We are going to see the crystals of potassium chlorate, the less soluble solid, crystals are going to crystallize out. So what we are going to do? We are going to filter it out. In the filter paper, we are going to collect the less soluble solid, that is potassium chlorate, and in the filtrate we are going to get the most soluble salt, that is potassium nitrate. And this potassium nitrate, on slow heating, when we heat it, and then we are going to cool it. After heating, when we cool it, on cooling we are going to get the crystals of potassium nitrate. So the crystals of the most soluble solid are going to crystallize out in the last. Firstly, we'll get the crystals of potassium chlorate, and lastly we are going to get the crystals of potassium nitrate. So what is the principle based on fractional crystallization? It is based on difference in solubility. Difference in solubility of the solids in particular solvent, and based on that we are able to separate the two solids, and this method is fractional crystallization. To sum up, what we have seen for solid-solid mixtures, what were some of the methods we saw? We saw sublimation. In sublimation, we saw the example of ammonium chloride being separated from sodium chloride. Secondly, we saw magnetic separation. In magnetic separation, we saw the example of iron filings being separated from sulfur using a magnet. Then thirdly, we saw solvent extraction. In this, one of the solids is soluble in a given solvent, and the example we took was charcoal and sulfur, and we saw that sulfur is soluble in carbon disulfide solvent. And lastly, the fourth method was fractional crystallization, and in fractional crystallization we saw the example of two solids which are having difference in their solubility. Example was of potassium nitrate, which was more soluble as compared to potassium chlorate. Okay, so in the next video we will be seeing the separation technique for solid liquid mixtures. Thank you, students.